From the vastness of space, Earth shines like a beacon, a vibrant oasis in the cosmic desert. This pale blue dot, as Carl Sagan so eloquently put it, is our only home. It's the only known planet in our solar system teeming with life. We see swirling clouds, vast oceans, and continents painted with diverse landscapes. This is our cradle, our life support system, a perfect balance of elements that has allowed life to flourish for billions of years. But what if we had to leave? What if some cosmic event forced us to seek another home? Our celestial neighbor Mars has long captured our imagination as a potential second home for humanity. Its reddish hue, visible even to the naked eye, has beckoned us to explore its mysteries. For centuries we've gazed at Mars, wondering if we could one day walk on its surface. Could we perhaps transform this alien world into a new haven for humankind? The challenges are immense. Mars, unlike Earth, is a harsh and unforgiving world. Its thin atmosphere, frigid temperatures, and lack of a global magnetic field make it a hostile environment for life as we know it. Yet, the human spirit is undeterred. We dream of reaching beyond our planet, of pushing the boundaries of what's possible. Earth is a remarkable anomaly in the universe, a cosmic oasis teeming with life. What are the factors that make our planet so special, so uniquely suited for life to emerge and thrive? One critical factor is Earth's position in the habitable zone, often called the Goldilocks zone. We orbit our star, the Sun, at just the right distance to have liquid water on our surface. Too close and water would boil away. Too far and it would freeze solid. Earth's perfect distance allows for the existence of oceans, lakes, and rivers that blanket our planet. Our atmosphere, a delicate layer of gases, is another crucial ingredient. It provides the air we breathe, a mixture of nitrogen, oxygen, and other trace gases. This protective blanket shields us from harmful radiation from the sun and helps regulate our planet's temperature. The Earth's magnetic field, generated deep within our planet's core, acts as an invisible shield, deflecting harmful solar wind that could strip away our atmosphere. Mars, in stark contrast to Earth's vibrancy, presents a desolate and unforgiving landscape. Its reddish hue, a result of iron oxide prevalent on its surface, hints at a planet long ago stripped of its life-sustaining elements. The Martian atmosphere is thin, about 1% the density of Earth's, offering little protection from the harsh solar radiation that bombards the surface. Temperatures on Mars are extreme, plunging to bone-chilling lows of -200 degrees Fahrenheit or -129 degrees Celsius at night, even during the Martian summer. Liquid water, essential for life as we know it, is absent on the Martian surface due to the low atmospheric pressure. While evidence suggests the presence of ice caps at the poles and water frozen beneath the surface, the lack of flowing water presents a significant challenge for any potential life. The thin Martian atmosphere, a ghost of its former self, poses one of the most significant hurdles to making Mars habitable for humans. This tenuous veil offers little protection from the relentless bombardment of solar and cosmic radiation. On Earth, our atmosphere acts as a shield, absorbing and scattering harmful radiation. This protective layer is crucial for life, preventing damage to our cells and DNA. Mars's thin atmosphere, unable to provide this vital protection, exposes the surface to dangerous levels of radiation. This radiation poses a severe threat to human health, increasing the risk of cancer and other radiation-related illnesses. Section 5. Cosmic radiation, the invisible threat to Martian life. Beyond the sun's radiation, another danger lurks in the depths of space: cosmic rays. These high-energy particles, originating from distant supernovae and other celestial events, constantly bombard our solar system. Earth's magnetic field acts as a shield against these cosmic bullets, deflecting them away from our planet. Mars, however, lacks a global magnetic field. This absence leaves its surface exposed to the full brunt of cosmic radiation, posing a significant challenge for future human explorers. Long-term exposure to cosmic rays can damage DNA, leading to an increased risk of cancer and other health problems. For any future Martian colonists, finding ways to shield themselves from this invisible threat will be crucial for their survival. Section 6. Robotic Pioneers, Unveiling Mars's Secrets. Despite the challenges, our fascination with Mars has only intensified. We've sent robotic emissaries to explore this alien world, each mission unveiling new secrets and bringing us closer to understanding the red planet's past and potential. Rovers like Sojourner, Spirit, Opportunity, and Curiosity have traversed the Martian surface, sending back breathtaking images and valuable data. They've analyzed the soil, studied the geology, and searched for signs of past or present life. These robotic explorers pave the way for future human missions, providing us with invaluable information about the challenges and possibilities that await us. Section 7. Building a home on Mars, a vision for the future. The dream of humans setting foot on Mars is no longer confined to science fiction. Space agencies and private companies are actively developing the technologies needed to make this dream a reality. From powerful rockets capable of carrying humans to Mars, to innovative habitat designs that can protect colonists from the harsh environment, we are steadily overcoming the technological barriers to interplanetary travel. The development of advanced life support systems, such as oxygen generators and water recycling technologies, will be crucial for sustaining human life on a planet devoid of these resources. Section 8. Terraforming Mars, a distant dream. Some visionaries dream of terraforming Mars, transforming it from a cold, arid planet into a more Earth-like world. This process, often seen in science fiction, would involve altering Mars's atmosphere, temperature, and ecology to make it suitable for human life. Ideas for terraforming Mars range from releasing greenhouse gases to warm the planet, to redirecting comets to deliver water and volatiles. While terraforming Mars remains a distant and technically challenging prospect, it sparks the imagination and raises profound questions about our relationship with other planets. Section 9. Conclusion. Earth's importance in the age of Martian exploration. As we stand on the cusp of a new era of space exploration, with our sights set on Mars, it is crucial to remember the importance of our home planet, Earth. This pale blue dot, teeming with life, is a precious and fragile oasis in the vastness of space. While the dream of colonizing Mars is a testament to human ingenuity and our thirst for exploration, it also underscores the need to protect and cherish the planet we already have. Earth, with its life-sustaining atmosphere, its magnetic field, and its abundance of water, is a rare gem in the cosmos. As we venture out to explore the Red Planet, let us do so with a sense of responsibility and wonder, knowing that our journey to Mars is not about abandoning Earth but about appreciating its uniqueness and ensuring its preservation for generations to come. For in the grand tapestry of the cosmos, Earth remains our most precious home, a reminder of the delicate balance of life and the importance of safeguarding our planet for future generations.